And now we are into the last session of the day, a super exciting session on how AI is transforming the manufacturing industry. So the title of this session is AI at the Convergence of IoT, Edge, and 5G. And the speaker is David King. David is CEO of Foghorn Systems. Foghorn Systems is a leader in edge intelligence software for industrial IoT. Prior to joining Foghorn, David co-founded Airtight Networks, a technology leader in secure cloud-managed Wi-Fi, where he served as chairman and CEO till 2015. Thank you so much, David. We are super excited to have you today, and over to you.
Thank you, Rahul. It's great to be here for many reasons. First of all, I guess wrapping up the day, you've heard about AI in the context of many consumer applications and in the context of retail, healthcare, a lot of different commercial usage of AI. What Foghorn has done essentially is bring AI into the world of industrial, and now increasingly as we go forward into the world of 5G, and I'll describe how all that comes together. So, Foghorn, the name itself, comes from a term Cisco invented maybe a decade ago called fog computing, which was really meant to be kind of the concept of next generation edge computing. And really the company's mission in the last 4 years has been to apply this concept of advanced or modern edge computing in the context of an IoT world. So we were thought of really in the early days as the leader in industrial IoT edge computing. Now, what we've done over the last 4 years is really move squarely to really sharpen the value proposition and the real purpose and meaning of fog computing to bring the world of AI, ML into the industrial world. And so industrial IoT is kind of a necessary kind of foundation layer to connect sensors and assets, right, to extract the data. But really the value comes from applying AI, ML, deep learning to that data. And so what I'll do today is describe kind of what we've done, talk about the company and our product is really an example of how you bring AI into this industrial context. So first, to explain, I'll talk mostly about manufacturing today, but the industrial world is much broader than that, right? Industrial encompasses not just discrete manufacturing. Everybody knows about manufacturing semiconductors, automotive, consumer packaged goods, industrial products. But there's also a lot of process industries that are part of the manufacturing world, things like chemicals, pulp and paper, agriculture, a lot of industries like that. Of course, there's also the resource industry, the energy industry, where you've got oil and gas, mining, electric utilities. You've got, obviously, the world of transportation, things like everything from jet aircraft to trains to fleet vehicles to passenger vehicles. And then you have the world of smart infrastructure, things like smart buildings, HVAC, elevators and buildings, all the way up into smart cities, where you now have cameras and microphones all over municipal areas. So industrial IoT is a massive, massive sector. It was really half the world's GDP is captured in those broad categories of manufacturing, energy, transportation, and smart infrastructure. So I'll talk more about manufacturing today, but you can imagine as we describe the use cases how this could apply in multiple sectors. So we're really pleased to have Intel Capital as one of our lead investors. In fact, led our last round of funding a couple of years ago alongside Saudi Aramco and Honeywell. And that came on top of a Series A funding about 3.5 years ago, that was co-led by GE, along with Bosch, Dell, Yokogawa, and some financial sponsors. And so our mission from day one has been to bring what we call edge intelligence, not just edge compute, which we consider kind of a generic term for collecting data, normalizing it, and then moving it somewhere else, but really bringing the power of AI, ML down to the source of the data. And so we'll talk about how this is different than kind of traditional edge computing as it's defined today by most of the world. And the company, I think when we started a couple years ago, was thought of as, I call it a fish swimming upstream, where everybody thought that AI, ML belonged in the cloud, and that the challenge of edge compute was simply to get the data collected and sent in a format that could be then acted on in the cloud or in a data center environment. And what we've done essentially is kind of redefined, if you will, the whole industry from thinking about IoT as a way of moving data, but rather bringing the power of the compute down to the data, right? Bring the cloud to the data, don't send all the data to the cloud. And therefore, I think Edge AI is really the best description of Foghorn's technology and our value proposition. So I'll just spend a minute on our stack because I think it's, we consider it best of class, but certainly first of class in this type of computing. So it's not just, simply inferencing or taking data and trying to execute a model on the data. It's actually bringing the entire kind of processing layer down to the data, and I'll explain why that makes a difference. So if you build models or train models in the cloud, right, whether it's ML, deep learning, AI type models, and simply bring it down to the edge, you're not necessarily going to get very good results because the data may not be in the kind of state or the quality, or may not be kind of synchronized to be able to execute models cleanly. And we started 3 or 4 years ago, people said you can't execute ML at the edge because the data is A, too dirty, B, coming too fast, and C, coming too asynchronously. And what we did essentially is say, no, there's a way to approach this problem by thinking about it a different way. And that different way is to actually put that full stack capability, right? The ability to not just cleanse, condition, normalize the data, what we call data enrichment in real time, but actually to bring the complex event processing, this term CEP, down to the edge. So this is a CEP that operates in tiny, tiny footprint, i.e. megabytes of memory, not tens of gigabytes of memory, at the source of the data on tiny compute. Right? So we had to invent a stream processing, think of it as a compiler, if you will, that can run and take data sources from any type. It can be traditional physical sensors like temperature, pressure, flow, torque, velocity, but it can also be things like vibration in the frequency domain, acoustic, video, imaging, any kind of data at any data rate, be able to take the data in real time on a streaming basis and be able to not only inference, right, to pull out the hyperparameters and score the model, but also to adapt the model and to improve the model. In fact, you can even train models if you have enough compute. And what we've proven is you don't need a ton of compute at the edge to train. Although if you get to really high frequency models like video or high speed imaging or 3D audio, you probably need a little heavier compute like x86 type computing. Now, essentially, what's the point of this? Why do you want this new layer of compute, that's a stream processing layer at the edge, and not send all the data to the cloud? Well, in the industrial world, there's already a huge amount of data being produced by existing sensors and a whole control automation layer called PLCs and other automation systems that are acting on the data in pretty simple format. PLCs essentially can do simple KPI execution on kind of a set of multivariables, but they can't do very complex transformations or calculations on that data. And they certainly can't execute learning functions. You can't actually kind of execute ML in a PLC. So effectively what Foghorn has done is to build this whole stack capability, the enrichment layer, the CEP, and the ability either to train at the edge with kind of standard algorithms or to import algorithms that have been pre-trained in the cloud or a data center, bring them down to the edge and do something we call edgeification, which is take the pre-processing layer and all the data alignment overhead of a model, right, Python, RStudio, Spark ML, doesn't matter what the language is, and pull that into the CEP function to make the model hyper efficient. So you're talking about a shrinkage of the footprint of the platform itself, about 100x. Now we're also talking about taking the models from gigabytes of memory down into megabytes, even kilobytes of memory. Why is that important? Because often the AI doesn't need to be just doing one thing. It may need to look at many, many different use cases on a single asset. So I'll talk about some of the use cases, the type of assets and processes we're dealing with. But the benefits for fundamentally, right, the ability to dramatically shrink the amount of data you have to transport across a network, right, which has security issues, but also a lot of cost issues. And you certainly don't have to persist it in a cloud or data center, right, unless it's valuable metadata, right? So instead of thinking about taking all the data to the cloud, process it and send the metadata insights and the outcomes, right, to the insights to a cloud. Second thing, of course, is the data security and privacy aspect of this. Why would you transport unnecessarily the OT data being produced by all these assets and processes that traditionally sit, by the way, islanded even from the corporate LAN? It sits in an OT network that's been, kind of firewalled off of the LAN and the WAN. And then finally, the real benefit is that you can also dramatically increase the performance, if you will, of the model. So the latency, sensitive applications, real-time applications, can frankly only be done if you're doing the processing live at the edge. And we'll talk about some of the use cases. So the other big advantage we discovered, especially as we've gone from kind of very high-speed complex analytics for real-time functions into the machine learning, deep learning, AI domain, is that traditionally in the industrial world, when you act on high-frequency data like vibration, and now with acoustic and video sensing coming into those environments, you typically downsample the data if you're going to persist it somewhere, right? Because you can't take the 1,000 measurements a second in a vibration sensor or all the frames in a 30 or 60 frame a second video stream and send it somewhere, right? You actually have to inference and process the data live. And by processing live, you're now inferencing on all the data all the time, not downsampled data. The bottom line is you're acting on higher fidelity data, and therefore you get better models, and you're able to iterate, adapt, and improve those models much more rapidly. So what is Edge AI? Edge AI in the context of industrial, or industrial AI, we would argue, is fundamentally just permanent, iterative, nonstop edge-to-cloud machine learning or deep learning. Right? We don't think it's a different category of applications. It's simply the application of ML and deep learning models on data that's constantly being tuned, tested, and improved. First of all, industrial assets age, processes change, so you do need to be able to adapt your model anyway because there's a passage of time. But more importantly, often the models aren't necessarily accurate to begin with or need to be adapted and improved as assets change. And so this idea of permanent nonstop inferencing is very, very important. So let me just spend a few minutes on some of the use cases. So I mentioned all the different sectors where this applies. It's not just manufacturing, discrete manufacturing, and process manufacturing. It's obviously energy, whether it's resource extraction like oil and gas and mining, or it's energy production, power generation, power distribution, the utility sense. It's also, of course, transportation of all types, and we won't get into those today, or smart infrastructure like buildings and cities. But in manufacturing, we can talk about some specific use cases for purposes of today. So there's a lot of benefit, obviously, of just getting much more refined-grained condition monitoring, predictive maintenance models on machine health for high-volume assets like pumps, compressors, valves, where a lot of people have been trying for years and decades to better predict the failure of those machines. So the edge computing in the context of an end-to-end AI system allows you to get what we call perfect predictive maintenance, knowing when to maintain the asset and exactly what to do when the asset begins to age and deteriorate. So the other thing that it can do is go way beyond just asset predictive maintenance, which was kind of the killer app, if you will, 5-10 years back. Really, it's about optimizing the performance of the asset in real time and improving processes iteratively in real time. And so the real breakthrough business benefits, especially manufacturing and in transportation, is the ability to do kind of this nonstop inferencing and improving of models. And so you're able to actually reduce scrap, increase yield, increase output in many of the factories. So we started out with GE, one of our early investors and customers, in their plants 4 years ago. And now we've literally served dozens of the world's largest manufacturers in many, many different domains. I mentioned the industrial products, consumer packaged goods, automotive, semiconductor, and the list goes on. We've also, of course, worked with a lot of traditional data sources like heat treat or cooling, or a lot of other systems that apply both in discrete, but especially in process industries, where you're looking at continuous flow of material to make a product. Well, those are extremely data-intensive environments, and the ability to build much more fine-grained models, right, to identify anomalies and to be able to perfect a process for operators on the floor makes a huge difference. Now, in manufacturing, as in all of our different domains, we've moved very much into the world of audio, video processing. So it started out for us with a lot of steel manufacturers, pulp and paper companies on vibration analysis around some of their big CNC rotating equipment, their pumps and compressors, where vibration has really been the new sensing type the last 5 or 10 years. But frankly, the models weren't perfect, right? They could get to 70–80% accuracy, but given the the hundreds of thousands, sometimes millions of these devices in the world, that accuracy is not good enough. You're right. You need to get it to like 5 nines, like the telco world talks about. And so the application of edge stream processing allows you to break through that barrier and get to kind of more perfect models by doing nonstop inferencing all the time. Now, as you go into video, what you find essentially is now you really don't have a choice. You can't just kind of reprogram PLCs or kind of take downsample data to the cloud anyway. You're talking about 30, 60 frames a second video. So how do you get rid of the false positives, right, for those kind of systems? And we've had a lot of experience recently, not just in manufacturing, but in oil and gas with one of our lead investors, Saudi Aramco, and our partner Schlumberger, of taking video analytics to the next level. And so, yes, you can hard code a lot of algorithms into the silicon to do video inferencing, right, object detection and such. But you need this ability to do much more advanced programmable processing, right, to get rid of all of the anomalies, if you will, right, all of the different sources of error that occur in these kind of models. So I did mention Saudi Aramco. We've done a lot of pioneer work with them on the application of video in oil and gas, right? Where it started out for us more in the midstream, downstream, of looking like something like a flare stack, right? A solution today consists of a lot of chemical sensors, thermal sensing at the top of a smokestack, trying to measure the gas content coming out of the stack, and a lot of cameras that look to identify when an event occurs. Well, reality is the video capability and edge processing, edge AI, on a camera can effectively replicate the human vision process, right? So rather the operator in the loop identifying when an event occurs and then doing kind of paper and pencil forensic analysis, you can actually do all the inferencing from the camera itself. You can measure the height, the angle, the smokiness, the color, adjust it for time of day, weather, and you can even measure the volume of the gas. You can do a lot of other things from just applying more advanced AI ML algorithms on the camera itself. Another area where we really started to move forward, and this is, I would kind of end by talking about our partnership with Mahindra, which is one of our best and longest standing partners, recently became a certified Foghorn developer. We're now working in the context of Honeywell and some of our other partners around now our mobile stack, which is the Android version of Foghorn, started out in Linux and Windows, running mostly on x86 and ARM systems. Now we're porting this to Android, where you can run this on mobile devices, whether it's in vehicles, but even in like handheld mobile computer platforms. So one of the things that we've done recently is to show how you can, when you get a defaced or smudged image in a barcode scanning setting or QR code scanning, to improve that image, to perfect it in real time, so that the operator doesn't have to scan it twice or basically leave the package behind because they can't scan it properly. We can actually perfect that image in the device in real time. So within a few milliseconds, you get the perfected image even as you've done the first pass scan. So those are some examples of how this technology applies in the world of industrial. And what 5G essentially will do for us going forward is not only be the foundational element for smart cities, right? Smart traffic management, smart surveillance systems, and of course, you know, to talk about 5G for autonomous driving and connected vehicles. Those are, if you will, the killer use cases for 5G. But even a lot of these other settings in manufacturing and energy, in other settings, 5G will be kind of the next step in being able to bring the power of AI ML down to the data, down to the edge. So with that, I'd like to thank everybody for participating today. Check out foghorn.io if you want to learn more about us. And if you've got any applications or clients that have needs in this area, we'd love to work with you. Thank you.
Thank you so much, David. So folks, with this, we come to the end of the summit. It's a pleasure to have you all join us this morning, Pacific time, and wherever you are. So just a couple of quick things we would like to leave you with. One is whoever have registered to join this webinar, you know, we're going to be sending a quick survey. Please fill it up and send it over to us. We are going to make sure some of the content that's presented today is made available to you. And to know more about the use cases across these industries, and also to know more about how we are helping some of the large enterprises within their journey of AI implementation, please visit us at techmahindra.com. And to know more about the portfolio companies within the AI space that Intel has invested in, please visit intel.com. Thank you again. We're signing off.